Hello there, aspiring statisticians. I would like to take this opportunity to go through some of the most missed questions on exam one. I know it's hard for some of you to come to campus to ask questions about your exam, so I'm hoping that this will help. What I did is I did an item analysis of all of the test questions, and any test question where fewer than 70% of the students got it correct made this list. You may have these exact questions from your exam. They may be similar to the one on your exam. There are roughly, 400 questions that are in our test bank. And so you may get the same question with different numbers, but it should be a pretty good starting place for you. Number 7 had 3 different versions, and I pulled all 3 versions of it. This is the only one where I know for sure what question number it was. The rest of them, you may have to hunt a little bit, but it builds character. 7 said the data was collected for 300 fish from the North Atlantic. The length of the fish in millimeters is summarized in the table. What is the class width? So the class width goes from the lower boundary of one class not boundary, the lower limit to the lower limit of the next class. So I'm going to come over here to my table. I like the green one. I'm going to use the lower limit for the first class. I'm going to look at the lower limit for the second class, and I'm going to subtract. So 120 minus 100 gives me 20, and 20 is the class width. The second version said to find the lower class boundary. Now this is very different from the class width. I'm going to draw these. Let's see, we're doing the 6th class. 1, 2, 3, 4, 5, 6. So this is my 6th class, and what I'm looking for with this lower class boundary is the number that's right between the 5th class and the 6th class. So what I'm going to do is I'm going to write these out sideways. I'm going to start with the 5th class. It goes from 196 to 199. And then we go from 200 to 203. And then 204 to 207. I didn't really need that last class, but it didn't hurt anything to stick it on there. I'm also going to change the colors of my dividers just so they show up a little bit better. So you can see the clear division among the classes. The lower boundary for the 6th class, remember this was the 6th, this is the 5th, this is the 7th. The lower boundary is the division line between the 5th and the 6th classes. And it is exactly between the upper limit, or the upper limit for the 5th class and the lower limit for the 6th class. So we need to average those two together. So I'm going to add 200 and 199 and divide by 2. That leaves me with 199.5 for my lower class boundary for the 6th class. The last version of 7 says the upper boundary for the second class. The upper boundary for my second class, here's my second class. So I'm going to write it out like I did last time. My brain works better that way. Let's set up my classes. I probably don't need all 3, but it's okay. So the first class goes from 60 to 61, 62 to 63, and then 64 to 65. The upper class boundary for the second class, here's our second class. The upper class boundary is the line that separates the second class from the third class. It is exactly between the upper limit of the second class and the lower limit of the third class. So we are going to average the upper limit from the second class, the lower limit from the third class, not a 3, not a 3. And that tells you that the upper boundary for the second class is 63.5. This is another question dealing with class width. We throw in sample size, and this time we're reading it from a histogram. So let's take a look at what the histogram gives us. We have, I don't know, some kind of data. And the height of each column tells us the number of people who fell into that category. So it looks like there were 7 subjects, 7 observations that had data falling in the 1 to 4 category. We had 6 that fell in the 4 to 7, 3, 4, 13 to 16 was 8, 16 to 19 was 10. I'm not sure what we're measuring here. Remember though that these across the bottom are like your classes. And then the vertical axis is how many times or how many things you have in each class. When you're reading a histogram and you're looking for class width, all you need to do is figure out how wide each of your rectangles is. Well, I know that the distance from 4 to 1 is 3. So our class width is 3. Now the sample size is the sum of all of the frequencies. So those numbers that I wrote on the blue rectangles, I'm going to add them up. So we need 7 and 6, that's 13. And 3 is 16. And 4 is 20. And 8 is 28. And 10 is 38. So the sample size for whatever study this is was 38. Here we have a line graph. In the lecture for these, we learned that the line graph was a really great way to demonstrate a change over time. But we also talked about different ways that graphs and different graphical representations of data could be misleading. And we wanted to look at why this particular graph could be misleading. Now, I didn't screenshot the different answer choices, so I'm going to work these off of memory here. One of the answer choices, I believe, said that the x-axis was labeled incorrectly or inconsistently. Well, remember that this is your x-axis. It's our horizontal axis. Typically, with a line graph, it's going to be labeled with time. It could be days, it could be weeks, it could be hours. It doesn't matter. We just want it to be consistent. So I'm going to check it out. We start with January. +1 would be February. And then March, April, and May. So it looks like I'm adding 1 month every single time. So my x-axis is consistent in the labeling. So that shouldn't throw anybody off. This is going to throw me off, though, if I don't put my picture back the way it was. I don't know why it wiggled. I probably touched it too long. A second thing that I remember seeing in the answer choices was that you don't have any data for toy sales after the month of May. That could be misleading if we were representing the number of toys each month sold over the course of a year, and they only gave us the data up until May. But we really don't have any information about the time span that should be included in this graph. So it's a possible answer, but I don't think it's quite the best one unless we had more information, like how much time this should cover. The other two answer choices that I remember were very, very close in nature. One said that the y-axis was not proportional or something like that. Oh, I know what it was. I think it said the dependent was the outputs. Outputs are not proportional. Something like that. And then the other one said that the y-axis was not consistently labeled. So I'm going to look at these together, and then I'll explain to you what I did on your exam. So the outputs are generally the y-axis. And normally when we consider things to be proportional, that means they're changing at the same rate. And so when I went to look at the outputs, from 0 to 100, added 100. 0 to 50 was a plus 50. We had another plus 50, another plus 50, and another plus 50. That first one was way bigger than the changes on the other ones. So I definitely could see choosing this outputs are not proportional as an answer choice. The other option was that the y-axis was not consistently labeled. And to me, if you have consistent labeling, then the change between each of these would be the same, and they're not. So depending on which one of these you answered you should have gotten credit for both of them because you could make a case for both of them to be correct. Okay, for this one, we are looking for the 80th percentile of the 19 data values shown. The 80th percentile in this case is our K value. So we are looking for P80. That means we need to find our locator. We need to find I. And you should have your I value formula either on the exam handout or in your notes. Your I formula says we need K divided by 100 times N plus 1. So we found K, that's the percentile. 19 is our N. Now this will not give us the answer. It will tell us where to go find the answer. So I'm going to plug in what I know. I know K is 80. My N value is 19. And I'm going to go to the calculator. I have 80 divided by 100 times 19 plus 1. If you can do that in your head, great. I do not do mental math very well. So I get 16. Now again, 16 is absolutely not your answer. Do not put 16 and put a box around it. This tells you the location of the 80th percentile. It's like when you go to a concert or a sporting event where you look at your ticket and it has a seat number on it. This is like your seat number. So we're going to go over to our big old list of numbers and we're going to find spot 16. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So spot 16 has 23.4. So our 80th percentile is 23.4. Okay, so these tables are ridiculously helpful when it comes to finding percentiles, if you know how to read them. What you need to know, because of this cumulative frequency idea, this first row actually covers, it's not just 21%, it contains 0 to 21% of the data. The next one goes from 21% to 42%. The next one goes from 42% to 64%. And then I go from 64% to 83%. And the very last one covers 83 to 100% of the data. So if we want the 18th percentile, we need to find 18% in the cumulative frequencies. Well, 18% falls in here. It is between 0 and 21%. So that means the 18th percentile for this frequency distribution of siblings is 0. If, for whatever reason, you were asked for the 42nd percentile. Now, I'm not trying to lose you. This is a what if kind of question, because this is one that you're very, very prone to miss if you're not real sure what's going on. The 42nd percentile occurs in 2 places. It occurs in the number of siblings, so 1 sibling or 2 siblings. It pops up over there twice on the right. So what we do is we split it. 42 is writing the line right here. So we want to average the number of siblings that are sort of straddling that 42 percentile line, or that 42% line. And that ends up giving you 1.5 for P42, just in case that should come up again. In this frequency table, you were asked to calculate the sample mean of the test scores. We could do that by hand, but I don't want to. If you want to do it by hand, it's totally fine. If I weren't using an iPad, I could very easily copy and paste my data, but I am using an iPad. So feel free to take this opportunity to, I don't know, let your dogs out, grab a snack, feed your kids, twiddle your thumbs, whatever. I don't recommend StatCrunch on an iPad or any tablet, really, for that matter. It really does seem to function best on a desktop or a laptop. So keep that in mind when you are doing some calculations. Now, to calculate X bar is the sample average. So I'm going to go to Stat and Summary Stats. Now here I have grouped or binned data because it's like having recycle bins. And I have a recycle bin that holds this stuff from 40 to 49. You know how plastic stuff has a number on the bottom for recycling? So maybe it has a number between 40 and 49 on the bottom. I know it didn't. Just go with it here. And then the second one, the second class, is the bin where we put all of the plastics with a number between 50 and 59. And then so on. So I'm going to use grouped and binned data. My bins, my recycling buckets, are in variable 1. The counts, that tells you how many things are in each one of your recycling bins. That's my frequency. So my counts are in variable 2. I don't care about where. We're not worried about limits. I'm going to go choose my stuff. All I want is the mean, so I'm going to uncheck all of these other things. And I'm going to click on compute. And it tells me that my mean is 66.35. We are rounding to 2 decimal places. So it'd be 66.35. So that's how you find the mean using StatCrunch. So the last question that really seemed to cause some problems were the standard deviation of the test scores. Thankfully, the classes are the same. I just need to change my frequencies. Okay. So again, I'm going to go to Stat. I'm going to click on Summary Stats. I'm still using grouped/binned data. My bins are variable 1. My frequencies or my counts are in variable 2. This time I want little s. Little s is the standard deviation for the sample. And so I have a standard deviation of 19.08 according to StatCrunch. Be very, very careful with StatCrunch. If you do not accurately load your data, obviously copy and paste can eliminate some of those errors. I just don't have that option on the iPad. That you accurately enter your data. Otherwise, StatCrunch is the fastest way to be wrong. So please make sure you are super careful in that. If you have individual questions about your exam that you want to address one-on-one, please send those to me. Don't hesitate to reach out because I would much rather do things for you guys than to do my own work. I'm a master procrastinator, and any excuse I have to not do my stuff, it's great. So let me know if you have questions or if I can help in any way. Otherwise, I will catch you in the next video.